Morning, distinguished guests, and to all participants. Welcome to Universitas Gadjah Mada, Yogyakarta for the 4th International Symposium on Marine and Fisheries Research 2021. My name is Retno Yulivenia, and it is a great honor for me to welcome you in this event, where we will share and exchange progress information, experiences, and research results in all aspects of marine and fisheries sciences. Before we start the program today, we would like to welcome with honor Vice Rector of Universitas Gadjah Mada, Ibu Ika Dewi Ana, PhD, Professor Rashid Sumaila from University of British Columbia, Professor Erlinda Cruz Lacierda from University of the Philippines Visayas, Professor Soottawat Benjakul from Prince of Songkla University, Dean of the Faculty of Agriculture, Dean of the Faculty of Biology, Dean of the Faculty of Agricultural Technology, Dean of the Faculty of Animal Sciences, and Dean of the Faculty of Veterinary Science, and to the head of departments in the Faculty of Agriculture, also to all distinguished guests and participants. I apologize if there are any mistakes in pronouncing the names and the titles. Before we proceed to the next segment, please allow me to read today's agenda. First, as the opening, we will sing the national anthem. Second, welcoming speech from Chairperson and Vice Rector of Universitas Gadjah Mada. Third, speech from the keynote speakers, followed by a question and answer session, and lastly, closing and announcement. Ladies and gentlemen, as the first agenda, we are going to sing Indonesia's national anthem, Indonesia Raya.
Aku berdiri Indonesia kebangsaan bangsa yang tanah air marilah kita bersatu Indonesia bersatu hiduplah tanahku hiduplah negeriku bangsaku rakyatku semuanya bangunlah jiwanya bangunlah badannya untuk Indonesia Raya Indonesia Raya merdeka merdeka tanahku negeriku yang ku cinta Indonesia Raya merdeka merdeka hiduplah Indonesia Raya Indonesia Raya merdeka merdeka tanahku negeriku yang ku cinta Indonesia Raya merdeka merdeka hiduplah Indonesia Raya.
Distinguished guests, without further ado, we would like to request the chairperson, Ibu Indah Istiqomah, SPI, MSc, PhD, to deliver her welcoming speech.
Thank you very much, Master of Ceremony. Good morning. Assalamualaikum warahmatullahi wabarakatuh. Excellency Ibu Ika Dewiana, PhD, Vice Rector for Research and Community Service, Universitas Gadjah Mada, Bapak Dr. Jamhari, the Dean of the Faculty of Agriculture, Honorable Keynote Speaker, Professor Rashid Sumaila from University of British Columbia, Canada, Professor Erlinda R. Cruz Lacierda from University of Philippines Visayas, Philippines, Professor Soottawat Benjakul from Prince of Songkla University, Thailand. Honorable speaker and audience, it is a great pleasure for me to welcome all of you to the 4th ISMFR. On behalf of the committee, we would like to thank you to join this symposium. Please let me introduce about this symposium. The 4th International Symposium of Marine and Fisheries Research is aimed to bring together researchers, academics, practitioners to share knowledge and research findings. The symposium is held biannually since the first establishment in 2015 in Yogyakarta, Indonesia. This year, we hold the 4th event by online platforms due to the global COVID-19 pandemic. But even though we are in this situation, we still have quite enough people to join with us, with about 152 scientific papers that will be presented by the speaker from 10 countries, including Canada, Norway, Japan, Belgium, Australia, New Zealand, Thailand, Malaysia, Philippines, and Indonesia. The 4th ISMFR theme is promoting sustainable fisheries through technology and research innovations for a healthy community. We chose this theme because we want speakers to present their research in all aspects of fisheries that are important for development of fisheries industry as the supplier of important fish nutrition to the world that facing the health crisis. We highlighting the presentation topic into 7 different groups with 3 main topics that include aquaculture, fisheries resource management, and fish product technology. Ladies and gentlemen, please take this opportunity to share and discuss your findings, which is at the end of the symposium, we can come up with new knowledge and idea on what we can do next to promote sustainable fisheries for healthy world community. Last but not least, I would like to express my sincere gratitude to Universitas Gadjah Mada, especially to the Department of Fishery, Faculty of Agriculture, all committee, and participants who can make this symposium happen. I really hope you will get a fruitful benefit from this event. Thank you for your kind attention. Please enjoy the symposium. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Erlinda R, PhD, for the welcoming speech. It is now my pleasure to introduce the Vice Rector for Research and Community Service of Universitas Gadjah Mada, Ibu Ika Dewi Ana, PhD, to deliver her welcome speech to officially open this event. Ladies and gentlemen, please join me in welcoming Ibu Ika Dewi Ana.
Thank you very much. Selamat pagi. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
All distinguished guests, keynote speakers, invited speakers, Dean of the Faculty of Agriculture, Deans of Universitas Gadjah Mada, Vice Dean for Research and Community Services of the Faculty of Agriculture, and participants. Ladies and gentlemen, the COVID-19 pandemic has become a global health crisis that has brought us to a new lifestyle that applies health protocols every day. In our university, we lost some of our colleagues because of that as well. The provision of nutritious and healthy fishery products by the fisheries industries plays an important role in strengthening a healthy and resilient society during the COVID-19 pandemic and beyond. In this context, Indonesia is one of the main contributors for world fishery production and is the second producer of fish from capture fisheries as well as aquaculture after China. Blessing with huge areas of water and oceans, the Indonesian fishery and aquaculture sectors are expected to be the primary mover of national economic growth while continuing to contribute to the global food supply. The development of fisheries and aquaculture should be directed to establish advanced, efficient, and robust industries that utilize fisheries resources with responsibility. As mandated in the Code of Conduct for Responsible Fisheries, utilization of fisheries and marine resources should focus on maintaining the quality, diversity, and availability of food for the present and future generations. Thus, science and technology in fisheries are required to improve and assure the efficiency as well as the sustainability of the production and utilizations of the aquatic resources. Accordingly, the synergy between research activities and development programs becomes very important, so that the research gives a real contribution in ensuring the optimum utilization of global marine and fisheries resources. All participants and distinguished speakers, UGM as one of leading university in Indonesia has taken part to contribute to the world fisheries sector. Since 1963, UGM has promoted the establishment of the Department of Fisheries in the Faculty of Agriculture. Collaborative research, academic activities, and community services have been being continued with Southeast Asian and European countries, United States, Australia, Canada, New Zealand, Republic of Solomon, Taiwan, Japan, China, and Korea. This symposium, the International Symposium on Marine and Fisheries Research, is organized by the Department of Fisheries UGM every 2 years, and this year is the 4th of the symposium. The symposium is an important platform to support the UGM's leading research in the field of marine and fisheries. This international symposium provides access for informations and exchanges of knowledge and experience in the field of marine and fisheries to support the transfer of knowledge and technology and to strengthen the world fisheries sector. Bapak dan Ibu sekalian, ladies and gentlemen, nowadays it is easier for us to collaborate each other to contribute to the society. We can share tasks among us. We can discuss among us by the utilizations of information technology, and we can improve the results to contribute to the society by the information technology, communication and information technology. That's why this platform is very important for us to strengthen and to restart the collaborative research, collaborative scientific works together. Ladies and gentlemen, on behalf of Universitas Gadjah Mada, I open the 4th International Symposium on Marine and Fisheries Research. Wishing all of the participants a fruitful symposium. Congratulations to the organizer, the Department of Fisheries, Faculty of Agriculture, Universitas Gadjah Mada. Thank you for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much, Ibu Ika Dewi Ana. That was a wonderful welcoming speech. Ladies and gentlemen, we are now entering the main session. First of all, allow me to introduce our moderator, Ibu Indun Dewi Puspita, MSc PhD, who will lead this session. Ibu Indun Dewi Puspita is a doctor in the field of applied microbiology. She has joined as a lecturer in the Department of Fisheries, Faculty of Agriculture, Universitas Gadjah Mada since 2006. She completed her PhD in Hokkaido University, Japan at 2012. Her research interests cover the area of microbial safety of fisheries products and applied microbiology for seafood waste processing. Ladies and gentlemen, Please join me in welcoming Ibu Indun Dewi Puspita.
Thank you very much, Ms. Fanny, for a very nice introduction. So, ladies and gentlemen, good morning. Assalamualaikum warahmatullahi wabarakatuh. It's such a great honor for me to be here, guiding all of the audience through the next 1.5 hours for the interesting presentation and discussion. So today we will have 3 keynote speakers that will share their expertise with us and their names through their papers that have been referred in your research. So I think this is a great moment for us that we can have meeting and also discussion with them directly today. So please allow me to take a few minutes to introduce our speakers today briefly. So first speaker is Professor Rashid Sumaila. He is the professor at the University of British Columbia, Canada, and he is a Tier 1 Canada Research Chair. For the information for the audience, Tier 1 Canada Research Chair are for outstanding researchers acknowledged by their peers as world leaders in their fields. So we are lucky today that we have him to be with us. And he has abundant experience working in fisheries and natural resource projects all over the world. He has published articles in many journals with a very high scientific index and has generated a great deal of interest. And he will deliver a topic on sustainable ocean economy for today. Second, Lacierda. She is a professor of fish pathology at the Institute of Aquaculture at College of Fisheries and Ocean Science, University of Philippines Visayas, and one of them was the outstanding book and outstanding monograph from the National Academy of Science and Technology. She served as project leader of the UP Visayas Department of Science and Technology. She has authored and co-authored more than 60 publications in books, scientific journals, manuals, and served as a reviewer for scientific journals related to aquaculture. Her talk today will be related to sea lice in Southeast Asian aquaculture. And I will introduce our third speakers, Professor Dr. Soottawat Benjakul. He is a professor in International Center of Excellence in Seafood Science and Innovation, Faculty of Agro-Industry, Prince of Songkla University from Thailand. His major fields of interest are the seafood quality, fish processing byproducts, non-thermal process, and natural additive for shelf life extension of seafood products. Within approximately 20 years of her career path, he has been named as several prestigious award recipients. He has published more than 850 research articles in peer-reviewed international journal indexed by Scopus. And today he is going to deliver his talk on process development and nutraceutical properties of hydrolyzed collagen from fish skin. So that is a brief introduction of our famous keynote speakers. So I think we are very lucky today. We have 3 of them being here with us. And before we start the presentation session, please allow me to remind all of the distinguished speakers that the allocated presentation time is 30 minutes. And please allow me to remind you if the time is about to finish. So ladies and gentlemen, without any further introduction, let's start our presentation session. And the first presentation, I would like to invite Professor Rashid Sumaila to deliver his presentation. Professor Rashid, the time is yours. I'm sorry, you're still in unmute mode. Professor Rashid, can you unmute your microphone?
Yeah, I think I'm
Thank you.
right. Okay. Yeah. So I was saying thank you very much for the introduction. But before I go further, I want to say assalamu alaikum to all of you. Peace be unto all of you.
Walaikum salam.
Alaikum salam. Thank you so much. And yeah, it's always a pleasure to either come to Indonesia or to have the opportunity to work with my colleagues in Indonesia. The last time when Yogyakarta, I'm trying to get the name of the city well. It was such a pleasure. We had so much fun. We learned together and did so many things. And I miss that. I wish I was there now so I can get to eat all the good Indonesian food. But okay, next time. Thank you for the invitation. And so the title of my talk is Identifying and Removing Barriers to Financing the Sustainable Ocean Economy. And so that is the thing, because recently I've dug into this and I'll tell you more about financing. Number one, we need a sustainable ocean economy, and the two doctors before me mentioned that. And to be able to do that, you really need to have good quality and the right amount of finance to go into the ocean economy, finance that supports nature, sustainability, and people. So that will be what I'll be discussing in this 30 minutes. So this is the outline. I will talk about why we need to have a more sustainable ocean economy and also funding for that, you know. And I'll start off by making the argument, which many of you already know, but it doesn't hurt to repeat these things, because we need to really integrate this, why the ocean is so important for us as people, so that we will learn to take good care of the ocean so it can take good care of us. So I start off by arguing that the ocean is actually our lives, you know. Without the ocean, life will be really, really unbearable on Earth. But the ocean at the same time is under threat. So, and we talk about the threats, there are many of them. And then the link to finance is that no matter how good your idea is, we all know that you can have the best idea in the world. If there's no finance, no financing, no investment, that idea can simply die. So good ideas can die at the altar of no finance or inadequate finance or inappropriate finance. So, and what I'm going to show that, or at least discuss and explain that current ocean finance is inadequate, both in terms of quality and quantity. So then the question is, what do you do? Why don't we have enough financing? So identifying barriers is very important starting point. Once you know what the barriers are, you can design policies and take action to actually remove the barriers. So that's the plan. And this is a figure I like showing. I know many of you already know it, if not all of you. But again, I like to say this, especially when I have policy makers, when I have government people who are not fisheries people, ocean people, right? The first important fact is that the ocean is 70% of the surface of the Earth. So if you have something and it's important to you, and you don't take good care of it, 70% of it, you are in trouble, right? I mean, this is a simple truism. What I tell my students is, if you were scoring 30% in your exams, you will never be in this class, right? So we need to take care of 70% of the Earth's surface. So it's too big to mess up or too big to ignore. Now, because it's too big, doesn't mean we cannot mess it up. We cannot put it under stress. We cannot degrade it, right? Number three, because it's big doesn't mean we cannot take care of it. You know, we people have the capacity, the brains, the resources, the machines or whatever to help us manage the large ocean sustainably in true time. Now, fish, we're talking about fish in the ocean, wild fish, marine fish, but it applies to fish in our rivers and lakes and whatever. So if you look at this picture, I'm just trying to stress how important fish stocks are and the number of things that depend on the fish stock doing well, right? From this fish, we have our capture fisheries, the wild fisheries. Indonesia is big on this, as it was mentioned, number 2 in many instances, and among the top 5, no matter how you look at it. Indonesia is huge. But even agriculture, which is, many people believe agriculture can solve our problem, a lot of the fish we farm actually need wild fish as fish meal and oil. So there is a connection. Seafood processing, all those working in the management, right? Think about research. I put marine research here. If not for the fish, I will have to look for another job, right? And because the fish is what keeps us going, we got to sustain it. It may be hard or not hard for me to get a job, but I will have to look for a job without the fish. So there are many reasons why we need to take care of the fish, because fish is the base for many economic activities. I like to say no fish, no food, no fish protein, no macronutrients. There is no fisheries, and therefore there are no fish jobs. There will be no rupees coming from fish, right? So we need to take care of this central resource. Now, apart from food and all, we get the economics. 60% of the world's population lives within 60 kilometers of the coast. I'm sure this number has actually increased now. This was on a paper that stated this years ago, right? So just think about it. And it generates, the ocean generates about 50% of the oxygen on Earth. So the ocean is our life, comes from this actually, because there's half-life doesn't mean anything, right? If half of our oxygen is coming from the ocean, then it's really central to our lives. The ocean regulates the Earth's climate, right? It is crucial for the Earth's environmental balance and survival, and therefore the survival of people, right? So there are all these big valuable stuff. Cultural and spiritual values. I mean, I had a PhD student who actually studied the spiritual values of the ocean to people in British Columbia, Canada, right? And did a whole thesis on this. It means a lot for people. Transport and shipping, without the ocean, the world will be in deep trouble. The amount of goods that go on the ocean to reach people is unbelievable. It's also recreation, there's tourism, ecotourism. You go to watch whales, you go to do all sorts of things with the ocean, and that's important. And of course, we have lots of jobs created, and Indonesia knows this, livelihoods of people, incomes for businesses, right? And it is a source of animal protein, food security, nutritional security. Very, very important. There are places in Southeast Asia, in West Africa, in Latin America, where fishing communities will have no animal protein in their diet without fish. So fish is very important. I just put out this to show you how important this is in terms of jobs, and not only globally, but also in large developing countries, including Indonesia. See here, when we estimated the number of people that depend on fish and fish or in the value chain, this is what we found. In India, millions of people. I mean, we're talking about what? My God, that's huge, right? And Indonesia is number 3. You have all the large developing countries, the Philippines and so on. And these jobs are important, security-wise. Can you imagine all the tens of millions of young people in these countries, if they have nothing to do, what it means socially, economically, and so on? You know, years ago, in 2016, I had the chance of giving a talk just after President Obama had given a talk. It was an amazing day, right? And I put out this graph and I said, you remember when Mr. Obama became president? He was a young, handsome guy, didn't have any gray. And within a few years as president, he became gray. You remember that? And without these jobs, I told them he would have been grayer, because this problem starts in Nigeria or in the Philippines, and they end up on the decks of our world leaders, including the US. So that's a huge service we get. All of these are happening, but the ocean is under threat. There are several threats. We are overfishing, we are catching the big fish, we are disturbing the habitat. You see that? Climate change is there, all the pollution, plastic, my God, marine debris, oil spills, so lots of stresses. I've not even mentioned ocean acidification, deoxygenation. So there are many issues that we need to tackle to make this sustainable. And this is just a picture just showing how climate change actually can affect life in the ocean. And the basic idea here is if the physics and the chemistry of the ocean is changing, the life of animals in the ocean will be affected. And so will our businesses. Our ocean economy will be affected. The fisheries will be affected. Our jobs, our food. So there's no how that the physics will change, and organism, populations, communities, and ecosystems will not be impacted. And if they are impacted, our fish stocks will be impacted, and therefore our fisheries will be impacted, and all the things we get from them. Now, this is some of the things I'm showing you. They are whole papers. I'm just dropping them, and I have some references if you want to dig further. This is a paper we did looking at the gains from meeting the Paris Agreement. If we are able to take the temperature to 1.5 degrees or between 1.5 and 2 degrees, what will be the benefits? And lots of billions of dollars we could save, mainly for tropical developing countries. Because as you know, the ocean is warming. Fish, like people, like any living thing, you have a range of temperature that you thrive in. If the temperature goes outside that, you either move and follow the cold water if you can, or if you cannot, you perish, or if you cannot move fast enough, right? And when we did all this calculation, what I'm showing you here is just a graph I took out of the detailed paper, which you can find and read. It's open access. And here on this x-axis, that is the change in the catch potential, maximum catch potential you can take, say from Indonesian EEZ, right? And that's on the y-axis and all. This is a global study. And here is the amount of CO2 per capita pumped out by either countries or continents. So you have Africa here, right? And you have South America, you have Asia here. So this gives you an idea. If we were to implement the Paris Agreement, the potential of the fish catch for Asia will increase by about this amount. And Asia is actually mid-level, this average for the whole continent. So some countries, of course, pump more, like Japan, I suspect, and some countries pump less, right, like Bangladesh. But that's the average. Now look at Africa, pumps very little per capita, and the gains are higher. So with climate change, Africa is a big loser compared to Oceania, even though they don't pump out so much CO2. Most of it is for we, the people in the up north, we do the pumping, and yet look at Iceland. Iceland will actually look at North America, right? And look, I think Iceland actually will do well with climate change because the fish will be moving there. So this is just to show you very quickly, but more explanations in the paper. The bottom line is this is a very moral, economic, and social graph. It tells you that what is happening with climate change is really not morally right. The people who pump less suffer more, and so on and so forth. So I thought I should share that. Another issue is illegal fishing and illicit trade. Another, in a recent paper we published last year, what we did was to try to trace IUU fishing, the illegal part, how it translates into illicit trade in fish stolen by illegal fishers and somehow landed into the economy. And so these countries and continents and the world actually loses legitimate revenues and economic impact. And as you know, Indonesia is famous on his effort to reduce IUU fishing, for example, which is a good thing to do because our estimate is that the world loses as much, nearly $50 billion a year of economic activity in various countries, including Indonesia, right? And look at the income to people working in the sector, tax revenues. And that is what, this is the conceptual framework we use to track this thing down. Again, just to kind of let you be aware of this paper and what we did. And I'm saying all this just highlighting some of the problems, all the stresses we're putting on the ocean, and the consequences in terms of economics, in terms of jobs, in terms of incomes. So all of this actually have impact on people, right? So these graphs, the top ones are from our group here at UVC, and this is from the FAO. And both institutions are showing that more and more we are taking fish from systems that are overfished and in some cases collapse or really depleted fish stocks. That's what this tells you. And the connection I'm making here is when we talk about sustainable oceans, ecosystem, marine ecosystem, of course, we care about the ecosystem, but actually the point is if the ecosystem is in trouble, people end up being in trouble. So here it is, the guy says, is that all the shrimp I get after all the work, right? So this is something you will all know. And fishers will go 6 hours and fill their boat before now they go a week and they can catch the same quantity and quality of fish. And here you have an example of an environmental refugee. This is becoming more again. So human beings have brains, right? If you are in your coast and your village and everything is going down, the fish are gone, you don't just sit down and starve. You move. That's why immigration is a human thing. I mean, so all these things are happening, making the connection from nature to this. Now, what do you do? In some cases, we argue that you need to rebuild depleted fish stocks. And these are all the kind of questions you have. In general, if you try to rebuild, nature is very kind. If you don't destroy it too much and you give it a break, it will come back. So one of the ways is to try to rebuild our depleted stocks. And our economics, that of the FAO and other colleagues, shows that if we have the guts to do that, we will move away from the current low fish stocks, the misery, to a better place where we can get more feed to feed people and support people's livelihoods in our coastal communities. Now, how do you achieve this? I say fix the economics. Economics is a very powerful tool. We react to economic incentives. Most of us do. So, for example, I think that commercial fishers should be allowed to fish only if they don't lose money, that they make money. If you are fishing, if you're an indigenous fisher or you are a subsistence fisher, I can understand. You can fish because you are fishing to feed your people. But if you're fishing to make money, you better make money. So no harmful subsidies, no subsidies that lead to overfishing. The WTO is working now to try to deal with that. Rather than use the taxpayer money to destroy the fish that people depend on, use it to support the fishery so it can support people. All right. Illegal fishing, I've talked about it already, and Indonesia is really familiar with this. Economists will say, make the economics not good for illegal fishers, and most of them will stop, right? Usually they do it to make money. That's a basic economic theory. And many of our fish stocks are shared with the high seas, with other countries. So collaborative management is important. And I'm sure Indonesia knows this. In many of the fishing grounds you fish, you are not the only country in there. There are other countries, you are adjacent to the high sea. So we need cooperative management. So these are all points that I think we need to work on in order to sustain our fisheries, not only for our benefit, but for those of future generations, our children and grandchildren. Then marine protected areas is in the news a lot. Economists, I love it because it's like buying insurance. You protect yourself from errors, from mistakes. So it should be part of your tools of trying to protect the ocean for the long term. All of these demand money. You need finance. So now I'm getting into the finance. And I'm showing you this. This is the cover page of our ocean finance report that we did for the high-level panel for a sustainable ocean, which is made up of 14 heads of state, including the president of Indonesia. So Indonesia is very central in this effort. These are current sitting heads of states from all over the world who have decided to come together with the leadership of the Prime Minister of Norway to really do the science, get science done, push the political system to ensure sustainable sustainable ocean, sustainable ocean economy. And the president of Indonesia is one of the leaders in this, which is great, right? Indonesia is an ocean nation in so many respects. Yeah, so what is an ocean economy? This is a simple summary. Many people define this in different ways. You have the extractable natural resources. It's also natural capital, and you have marine and coastal development, knowledge, even the creation of knowledge and creativity. All those are part of the ocean economy, and you have windmills and renewable energy, all those. So our report tried to talk about how to support this through ensuring that adequate finance goes into the sector. Now, some key messages here. The ocean is a cornerstone of the global economy, contributing trillions of dollars. According to the OAC, 1.5 OECD, I meant to say, $1.5 trillion is what the ocean generates. And when we look at the details, less than 1% of the ocean economy is actually used to finance the protection of the ocean. Many of us will say, this is too low, come on. You generate 100 and you get only a rupee, right? That doesn't make sense, so we need to do that. And with all the things happening to the ocean, as I outlined, we definitely need to do more. To do this effectively and achieve a sustainable ocean economy, significantly greater finance needs to be made available. That's what we found. And I should have added, one of the authors of the ocean report and the paper that came out of it is Indonesian, Anna Suzy, actually. And so this is a global effort. There were 23 of us and from all over the world who put this thing together. So it's quite a diverse group. Now, talking about the barriers and opportunities, we itemize a number of barriers. Again, please, the report is available. We had a paper which we published in Nature Communications on World Ocean Day this year, on June 8th. You find it is open access, and we detail all this. For this talk, because of time, I will just summarize very quickly. So some of the barriers we found was distorted market dynamics. So you have all these subsidies messing up things. You have high financial insurance has a role to play also. So that is one thing. We need to reduce the risk so that businesses can create innovative products and help us deal with that. And then you have gaps in information and knowledge, capacity building. We need a lot of young people to really get the knowledge so they can create these creative instruments to help get the necessary good quality finance together. I say good quality finance. There's a lot of money going into the ocean. Say, for example, oil and gas. According to the IMF, $4.7 trillion of subsidies go to oil and gas. If you ask an economist like me, no, that's not what you want to do because of all the externalities, the CO2 that is pumped out from that sector. So that's a lot of money, but it's not good quality money in the sense of sustaining our ocean economy. So you'll find a lot of this in the paper. And then we talk about opportunities, how to really improve this. And that's on this side of establish effective and stable regulatory environment. So you create the enabling environment so that individuals and companies and NGOs, everybody can go in there and actually contribute. And this basket here is made up of all sorts of new things, the new instruments that are being developed, like debt for swap schemes. In the Seychelles, for example, the Paris group of countries creditors decided to reduce the interest payment of Seychelles, their debt, so that the savings can then be used to support managing the ocean. That's a clever thing, and there are many such instruments. So I put this graph here just to tell you two things. There are different types of funding sources. You can take on debt, which I don't recommend. You can do blended finance, or private sector and government, and you can do impact only investing, and you can use equity. You can do stocks and actually put them on the public, and all of these are being developed by all sorts of countries, South Africa, Ghana, Indonesia. There's a lady in Singapore, she has an outfit to create bonds to support women businesses in Asia and around the world. So you have a lot of creativity going on. Now, enabling environment is important. I've actually talked about this thing. Redirect the harmful subsidies. We are not saying take the money, but let the money work for people and the environment rather than undermine the environment and then harm people. You realign economic incentives, your tax systems, your fees and levies. Those who create externalities, negative externalities, cause harm to people, other people, and to nature, should actually be made to pay. Let the polluter pay. You remember that. Insurance can play an instrument and catalyzing new investments. And I've given some examples of that. Now, very quickly on MPAs, this is a study from Europe. They kind of found out that actually it can be good business to really protect your environment properly, because this study, more than 100 scientists and economists of the world actually made an estimate, and we found out that for every dollar you spend defending and protecting your ocean to make it sustainable, you can get $5 back, which is not a bad deal at all. So a list of some of the barriers, government and public institutions. Essentially here we are saying we need all sectors. It's not only government or the private sector or even individuals or NGOs. Every institution has a role to play, including individuals. So we itemize that. I won't get to go through each of them, but at least that is the list for you. And in the paper and in the report, you find more about this. Addressing barriers, there is a role again for all sectors. Private finance is needed in many places. Increase finance and investment in a sustainable ocean economy. I told you that we use less than 1% of the economic impact generated from the ocean. How about we make this 2%, 3%, 4%? That will bring in more resources to create the environment so the private sector can do a good job at financing a lot of this. And yeah, there's more here on how to do this, and I think I wouldn't go into them one by one, but essentially the point is there are barriers and there are ways to deal with those barriers. And I think I'm at the end of this. I want to thank you all for the opportunity to do this, and I look forward to questions and answers. I hope I'm within my time. Thank you so much.
Thank you very much, Professor Rashid, for the very interesting presentation about how important the sustainable ocean economics, and also the explanation about the barriers and opportunities to the ocean finance. I guess there are many questions that the audience would like to ask. Please, for the audience, if you have any question, you can type your question in the comment column under the Zoom menu in your computer, and then we will go through the question and answer session later on. So, Professor Rashid, do you still have time until the end of the plenary session for the question and answer? Okay, thank you.
Thank you. I'm here.
Thank you. So now let me proceed to the second presenters. We have Professor Erlinda, who will give a talk about the sea lice in Asian aquaculture.
Okay, good morning, everyone. And probably good afternoon and good evening to our other colleagues in other parts of the world.
Good morning, everyone.
Before you play you have started? May I take this opportunity to personally thank the organizers of the 4th Ismfr 2021, especially to Dr. Inda for inviting me to be part of this symposium, and to, of course, to all the staff of University Gadjah, Mada. Thank you very much. Okay, so maybe we can start now.
Okay.
Good morning, everyone. The title of my presentation is Sea Lice Research in the Southeast Asian Aquaculture. The Southeast Asian region offers a great potential for marine aquaculture. Marine fish production in the region is focused on high-value species such as groupers, snappers, and sea bass for the live fish market. Other marine species commercially cultured are siganids, pompano, cobia, and milkfish. Culture of these species are done in square or circular floating net sea cages using various kinds of materials such as wood and high-density polyethylene for the cage framework. The rapid growth of aquaculture activities in the past decade, brought about by the increased demand and intensification, led to an increased environmental impact and an increased risk of infection with disease-causing agents. Pathogens such as bacteria, parasites, and viruses are introduced into the cages through the seedlings or are simply transferred through wild stocks living in the surroundings. Parasite infection among cage-cultured fish has been a major problem in the aquaculture industry, including the ASEAN region, threatening its production efficiency, economic viability, and the long-term sustainability. In the ASEAN region, sea lice have emerged as one of the most dangerous parasitic copepods. Their impacts range from mild skin damage to stress, osmotic problems, secondary infections, and mortality. In Thailand, about 80% of sea bass farms have been observed to have sea lice infection that resulted into 30 to 50% loss of stock. This presentation provides the current state of knowledge on sea lice in aquaculture in the ASEAN region, including a brief biology of sea lice species that have been reported in the region, the identified significant species of sea lice in the region, and some known treatment measures to control the infection. Information were sourced from published materials and through communication with sea lice researchers in the region. Research needs of the region are also presented. Okay, for the biology of sea lice belong to order Copepoda and family Calligidae. The body is dorso-ventrally flattened and divided into 4 parts: the cephalothorax, the fourth pediger, the genital complex, and the abdomen. The cephalothorax is responsible for attaching to and performing rapid locomotion on the host fish. On the ventral side, the cephalothorax carries paired appendages, including the antennae and the maxillae, which are used as clamps. Sea lice feed on mucous epithelial cells or blood of their host by pressing their tubular mouth onto the host's skin and grazing the tissues using their mouth parts. The fourth pediger provides major flexion of the body, and it carries the fourth leg. The genital complex is a storage area for the gametes. The abdomen, together with the paired caudal rami, function as part of the rudder in swimming. Sexual dimorphism is recognizable in adult sea lice. The female is larger than the male. The female has a more prominent genital segment than the male. Paired egg strings are produced by the adult female from the posterior portion of the genital segment. Globally, more than 500 species of sea lice have been reported, and about 45% of these are reported from Asian waters. Sea lice have 37 genera, with Calligus and Leptopterus as the most common. About 250 species of Calligus and more than 100 species of Leptopterus have been identified. The lunules are an accessory attachment organ and are present in Calligus but absent in Leptopterus. The morphology of the fourth pediger, the genital complex, and the fourth leg are used to differentiate between genera. Generally, the life cycle of Calligus comprises 9 stages and 10 stages in Leptopterus. In Calligus Epidemicus, however, 11 stages have been described. The eggs hatches as nucleus 1 and molts into nucleus 2. Nucleus 1 and nucleus 2 are non-feeding. They are planktonic and positively phototactic. The nucleus 2 develops into an infected copepodid, and the planktonic copepodid must find a host in 3 to 4 days. The copepodid will attach to the host by means of its antennae. The attached copepodid develops into Chalimus 1, molts into Chalimus 2, 3, 4, 5, and 6. All the Chalimi stages are sessile and parasitic on the host skin. Chalimus 6 develops into the pre-adult stage, then the adult stage. The pre-adult and adult stages are mobile and parasitic. The whole life cycle is completed in 17 days at temperatures of 24 to 25 degrees centigrade and a salinity of 20 ppt. Per unpublished data of the group of Dr. Kua in Malaysia, the life cycle of Calligus epidemicus is completed in 8 or 9 days at 27 degrees centigrade and 28 ppt. In the next few slides, I will present the sea lice species recorded on farmed and wild-caught fishes in the region. The list herein presented may likely be incomplete as there are many unpublished materials and or written in languages other than English. Table 1 shows a list of reported sea lice from farmed fishes in Indonesia with 2 identified species and a number of unidentified species of Calligus and Leptopterus parasitic on various grouper species. This list has been kindly verified by Dr. Isti of Fisheries Research Center of Jakarta and Dr. Hilal Anshari of Hanasudin University. Calligus patulus on farmed milkfish was mentioned in a 1980 publication. Recently, Pseudocalligus uliartus has been reported to have caused mass mortality among breeders of 2 sigonid species maintained in floating cages. Incidentally, the valid name for Pseudocalligus now is Calligus based on recent molecular studies. But for easier reference to related literatures, I will refer to it as Pseudocalligus. From wild-caught fishes in Indonesia, species 14 species of sea lice have been recorded parasitic on 16 host fish species belonging to 4 orders and 12 families. In Malaysia, 8 species of Calligus and a number of unidentified Calligus species have been reported among farmed fishes. High fish mortalities have been associated on Calligus or with Calligus Epidemicus and Calligus minimus on snapper, grouper, and sea bass. Calligus rotundinalis infection also caused mortalities in snapper and hybrid grouper. A number of unidentified Calligus species have also been recorded on sea bass, snapper, cobia, and grouper in 1980s. It appears that the important species of sea lice on farm fishes in Malaysia include Calligus epidemicus, minimus, and rotundigenitalis infecting sea bass, snapper, and grouper. It is noted that after the reports in 1980s, the succeeding works on sea lice came in 2009 and thereafter. 10 species of sea lice have been recorded on 10 species of fish caught from the wild in Malaysia. Okay, Table 5 gives a checklist of sea lice species on farmed fishes in the Philippines. Calligus epidemicus was recorded on 10 host fish species belonging to 3 orders and 8 families. Calligus epidemicus on sea bass and siganid. Calligus patulus on milkfish, and Leptopteris spinifer on pompano were associated with diseased condition and or mortality of host fish species. However, there was no record of disease condition or mortality due to Calligus patulus infection since its first report in 1977. Thus, based on these findings, Calligus epidemicus and Leptopteris spinifer are the most important sea lice species on farm fishes in the Philippines. Table 6 gives the 15 sea lice species recorded from 20 host fish species from the wild in the Philippines. Calligus epidemicus has been recorded on 4 host fish species belonging to 2 orders and 4 families. From farmed fishes in Thailand, I could only retrieve the works of Dr. Chinabut, and there may be more, but it appears that Calligus epidemicus is a significant sea lice species in the country. Table 8 shows the sea lice species parasitic on wild-caught fishes in Thailand. 7 species of sea lice and a number of unidentified species of Calligus have been recorded from 14 host species. It is very likely that this list is incomplete, as only 3 reports could be retrieved, one in 1996, then in 2007, 2008, and in 2020. It is also highly possible that only a few scientists in Thailand are working on sea lice. Table 9 shows the reported sea lice species parasitic on farmed fishes in Vietnam, It shows that Calligus epidemicus infects sea bass, grouper, red tilapia, and cobia. Table 10 shows the 5 species of sea lice, parasitic on 4 host species caught from the wild in Vietnam, and an unidentified species of Calligus and Leptopterus. Similarly, these 2 tables could be incomplete as there are many materials written in Vietnamese language that could not be retrieved. Based on this information, 42 sea lice species, parasitic on farmed and wild-caught marine fishes, have been recorded in the Southeast Asian region. Globally, this represents about 10% only of the known species. There may be many unidentified species, but only a handful of researchers are working in this field. So I take this opportunity to encourage our students and young researchers to consider this potential field of research. Among the sea lice species reported in the region, Calligus epidemicus, Calligus minimus, Calligus rotundigenitalis, Leptopterus spinifer, and Pseudocalligus uniartus are considered as the most important species, causing disease conditions and significant mortalities among infected host fishes. Next, I will discuss the 5 most significant sea lice species in the region. First is Calligus epidemicus. In our paper, published as Ho et al. In 2004, Calligus epidemicus was recorded on all 10 host fishes examined. This indicates its low host specificity, often at 100% prevalence, at varying intensity of infection, as high as 5,000 on a single host fish, as observed in surgeonfish. In our 2011 paper, we reported sea lice infestation among cyganid breeders in land-based tanks and pond-reared sea bass fingerlings. Sea bass breeders showed extensive erosion and hemorrhagic lesions on the anteroventral side of the body surface, including the pectoral and pelvic fins and the eyes. A 10% mortality was recorded among infected fish. Heavy infestation of sea lice was observed on the cyganids, where 96% of the sea lice load was Calligus epidemicus, with a mean intensity of 400. Infected sea bass showed lethargy and reduced growth rate, with 100% prevalence of Calligus epidemicus and a mean intensity of 12. Okay, table 12 shows the fish hosts of Calligus epidemicus reported between 1971 to 2019. It shows that Calligus epidemicus has been reported from 42 fish species belonging to 17 families and 4 orders, indicating its low host specificity. The table also shows that the Calligus epidemicus is widely distributed, having been reported in the ASEAN region, including the Philippines, Thailand, Vietnam, Malaysia, and Indonesia, as well as in other Asian territories, including Taiwan, Australia, India, and New Zealand. It has caused disease conditions and significant mortality in farmed fishes, including milkfish, mullet, pompano, tilapia, snappers, cobia, groupers, sigonids, bream, and terrapon. Calligus epidemicus has been reported to occur in salinities of 2 to 32 ppt. Another important sea lice species in the region is Calligus rotundi genitalis. Okay, table 13 shows the reported host species of rotundi genitalis in the region, belonging to 2 orders and 6 families, causing significant mortalities in sea bass, snappers, and hybrid grouper in Malaysia. In Taiwan, Calligus rotundi genitalis has also been reported from 33 fish species belonging to 19 families. So this indicates that Calligus rotundi genitalis has low host specificity. In cage-cultured crimson snapper and emperor snapper in Penang, Malaysia, sea lice-infected fish showed hemorrhages on the caudal fin. Areas on the body are devoid of scales with associated mortality. Large numbers of Calligus rotunditinalis with a small number of Calligus epidemicus were observed, with a prevalence of 81% and a mean intensity of 5.6. Infection was observed in salinities of 19 to 32 ppt in Indonesia and 25 to 28 ppt in Malaysia. Next is Lepidopterus spinifer. In our 2011 paper, we reported marketable sized pompano exhibited extensive skin lesions, thereby considerably reducing its commercial value. Affected pompano had 100% prevalence of Lepidopterus spinifer with an estimated intensity of 50. At the Igang Marine Station of Siftec in Guimaras in the Philippines, L. spinifer infection perennially occurs on the body surface, fins, and eyes of the pompano breeders. We looked at the seasonal population dynamics of L. spinifer infecting the pompano breeders by daily measurements of the water temperature and salinity from the infected cage from September 2018 to May 2019, covering the warm season, which is from March to October, and the cold season from November to February. Water temperature at 29 degrees to 29.4 degrees centigrade in September to early November are not significantly different. Temperature starts to drop in mid-November and significantly lowest at 27.5 degrees centigrade in January to mid-February, and starts to increase again in March and significantly highest at 30 degrees centigrade in April and May. Mean water salinity ranges from 30.5 to 32.5 ppt in September to December, and significantly highest at 34.5 to 35 ppt from January to early March, and then significantly drops from mid-March at 33 ppt to May at 30.5 ppt. Population of L. spinifer maintain 100% prevalence throughout warm and cold seasons. However, mean intensity increased only during the cold months, which is from early November to early March, with the highest mean intensity in early January at 200 at a temperature of 27.5 degrees centigrade and a salinity of 35 ppt, while the lowest mean intensity was recorded during the warm months, dipping into 12.5 in early May at a temperature of 30.5 degrees centigrade and a salinity of 30 ppt. Our result is in contrast with previous studies on the seasonality of Calligus populations in temperate regions, wherein mean intensity generally peaks around the warm period of the year. Whether this observed seasonality is uniquely exhibited by Leptopteris spinifer or is also shared by other sea lice in tropical environment require further studies. Prevalence of adult males and adult females was high throughout the monitoring period. Pre-adults also had high prevalence, except at the start of summer in late March to early May. Chalima stages were observed only during the cold months, specifically from early November to late January, with prevalence of 40 to 80%. Highest mean intensity was in early November, which coincided with the first peak of the total L. spinifer population. This indicates that while adult male and adult female spinifer are present throughout the year, active and successful reproduction only occurs at certain period of the year, especially during the cold season. Table 14 shows the recorded host fish species and distribution of L. spinifer. It appears that L. spinifer is highly host-specific to Carangidae, including queenfish and pompano. It has been reported in Sri Lanka, India, Australia, and the Philippines. It has caused severe skin damage on wild-caught queenfish, as well as in farm-reared pompano, thereby considerably reducing its market value. During high L. spinifer infestation, severely affected fish showed hemorrhagic areas, particularly on the eyes and the operculum. Some exhibit exophthalmia and thus are blind either on one eye or both. Vibrio harbaei was isolated from the exophthalmic eyes of spinifer-infected pompano broodstocks, and the authors attributed exophthalmia and Vibrio harbaei infection in host fish as initiated by L. spinifer. The next is Calligus minimus. Calligus minimus infection has resulted to high mortality in farmed sea bass, crimson snapper, and hybrid grouper in Malaysia. It has also been observed in at least 5 host species caught from the wild. C. minimus has been reported in 3 orders and 8 families, indicating its low host specificity. The life cycle of Calligus minimus from sea bass is completed in 5.5 to 7 days at 30 degrees centigrade and 25 ppt, indicating a short life cycle. Recently, juvenile hybrid groupers in Perak, Malaysia experienced high mortalities. Fish were very thin and not feeding. Within the buccal cavity of the affected fish were large numbers of reddish nodule-like outgrowths. The nodules contained large numbers of encapsulated Challimai stages of Calligus minimus. Okay, last is the Pseudocalligus uniartus. Pseudocalligus uniartus has been recorded on mangrove snapper and siganid in the Philippines. It has caused high to mass mortality among breeders of siganids in South Sulawesi, Indonesia. Heavily infected fish showed extensive lesions on skin and eroded fins, and large numbers of Challimai stage of Pseudocalligus uniartus were attached on siganid fins. The attachment and feeding sites of the Challimai stages showed inflammatory cells. The life cycle of Pseudocalligus uniartus was reported to be completed in 7 to 10 days at 27 to 29 degrees centigrade and a salinity of 34 to 35 ppt. Ho in 2000 listed 9 species of sea lice to have caused mortalities among non-salmonid fish in Asia. This includes Calligus acanthopagri, Epidemicus orientalis, Patulus punctatus, Rotundi genitalis, Calligus spinosus, Lepropterus longiventris, and Lepropterus paralictidis. Among these 9 species, 3 species, Calligus epidemicus, Patulus, and Rotundi genitalis, have caused mortalities among farmed fishes in the Southeast Asian region. To update this list based on the data presented, 3 additional species are recognized: Leptopterus spinifer, Pseudocalligus uniartus, and Calligus minimus, to have caused significant mortalities in farmed marine fishes in the Southeast Asian region. Various treatment methods have been tried to control sea lice infection, but it remains a problem. Early efforts to control Calligus patulus on milkfish breeders used Negvon, a trichloroform, but the compound renders potential risks to both the handler and environment. Short bath treatments of formalin, potassium permanganate, hydrogen peroxide, neem oil, as well as oral treatment with imamectin benzoate have been reported to control various species of Calligus. Manipulation of alkalinity of the culture water have also been tried to control Calligus minimus infection on Lattes calcarifer. Freshwater baths are regularly and repeatedly employed at fish farms for control of sea lice, but it is very difficult to completely eliminate the parasite as reinfection occurs soon. Treatment and handling of fish puts additional stress on the infected fish, and bath treatments are efficacious on parasites attached on body surface, but not on those in the buccal cavity. In Indonesia, water at the surface layer of rearing facilities are removed as developmental stages of sea lice are attracted to light. Okay, here's a list of what I believe are needed for research. In the region, reports on sea lice are generally limited to description of sea lice occurrence, while in-depth studies on the ecology of this species are scarce. Thus, studies on population dynamics of sea lice at different culture systems and controlled studies to determine the impact of water temperature on the growth and reproduction of sea lice are needed. Pathology or the impact of sea lice on the fish host is also needed. Much work on efficient measures of control and treatment against infection are still wanting. And although sea lice pose a high threat to the development of cage farming in the region, ironically, there are only a handful of specialists in Southeast Asia working on sea lice. In the Philippines, fish parasitologists have either retired or have passed away. This shortage of sea lice specialists must be overcome if marine cage aquaculture in the region is to be developed into a large-scale operation. To summarize, about 42 sea lice species have been recorded among farmed, reared, and wild-caught fishes in the Southeast Asian region. Globally, this represents about 10% only of the known sea lice species. Among these, Calligus epidemicus is the most dangerous species. Calligus rotundinatalis, Calligus minimus, Calligus uniartus, and Pseudocalligus uniartus, and Leptopterus spinifer are potential threats in marine aquaculture in the region. A number of control and treatment measures have been explored, but sea lice infection remain a problem. Chemotherapy should not be used alone, but should be a part of an integrated health management strategy. Studies on the ecology, pathology, and control of sea lice infection are warranted. And fish parasitologists specializing on parasitic copepods are needed. I'd like to take this opportunity to thank the organizers of the 4th Ismfr 2021, headed by Dr. Inda, and University Gadjah Mada, Dr. Leong Tak Seng of Malaysia, Ms. Isti Sugama and Dr. Hilalar Anshari of Indonesia, and Dr. Kowa from Vietnam for their assistance in acquiring the important literatures as well as photographs. And Peter Palma and Daryl Superior of SIFTEC for some photographs and also the important literatures. Okay, thank you.
Thank you very much, Professor Erlinda, for interesting presentation about the comprehensive scientific information about the sea lice, which is one of the important parasite that impacting the aquaculture, specifically in mariculture and wild-caught fish in Southeast Asian region. We will have a further discussion with Professor Erlinda in the question and answer session after the presentation. Thank you, Professor Erlinda.
Thank you also.
Let we proceed to the next speakers, the last but not least, and a very important and interesting topics. also about the economic value, increasing economic value from the seafood waste. So I would like to invite Professor Soottawat Benjakul for the presentation. Time is yours, Professor.
Thank you, Dr. Inda.
I'm sorry, can the committee, okay. Please, Dr. Soottawat.
Hey, Tata. I cannot extend.ให้มันใหญ่ข้างบนผมต้องชื่อเข้าใช้เอ้าอะไรไม่ใช่สิ sorry โอเคไม่ได้ในแค่นี้อ่ะ
The slideshow
Is
button?
full screen? You can see the full screen?
Not
okay.
Yet.
All right. Okay.
Okay. It's
sorry.
Okay,
sorry. Okay. All right. Thank you, Dr. Inda, and also good morning, ladies and gentlemen. So it's my pleasure and honor to be the speaker for the plenary session. For my talk today is Hydrolyzed Collagen from fish skin, with emphasis on the quality improvement and nutraceutical properties. Actually, the fish and fish product has become very important income generator for Thailand and also Indonesia. And during fish processing, a large amount of the byproducts or leftover are generated, like a head or skin or bone, for example. And for fillet production, this skin is implemented either by machine or by hand, and the skin is generated, and skin has been used as a snack, for example, by deep frying, or in you can see this kind of product is the deep fried skin coated with the salted egg, which is popular in Singapore and Malaysia. And to increase the value of the skin, we can produce the collagen from the fish skin with a higher market value. So what is collagen? So collagen is a protein consists of 3 alpha chain unite each other. We call tropocollagen, and each alpha chain have molecular weight around 100,000. So totally the tropocollagen have molecular weight around 300,000. And along the chain of the alpha chain, they have the glycine every 3rd position, except there are 14 amino acids from N terminal and 10 amino acids from C terminals. So I would say that the glycine constitutes around 1/3 of the collagens, and collagen also consists of the amino acid, especially hydrogen proline. And the source and where we can produce for collagen. So collagen can produce from the fish skin, scale, bone, or even swim bladders. And for this my talk today, I'm gonna focus on the ASEAN sea bass, because the ASEAN sea bass is have a lot of farm in Lake of Songkla close to my university, and also ASEAN sea bass are very popular species in ASEAN, Southeast Asian countries. So actually, collagen can be extracted by acid solution, especially acetic acid at low temperature. However, the collagen obtained have the low yield, so pepsin have been applied. What happens is we have pepsin. So pepsin specifically clip at telepeptide region here. You can see that. So tropocollagen normally link together and form the fibrils. And when we cut these regions, those tropocollagen can be leached out easily, as you see here. And that's why we can end up with a higher yield when applied for pepsin. And normally the native collagen is a Taiwan collagen. But, we have actually 28 types of collagen, but basically the collagen from skin or scale is Taiwan collagen. But based on the processing, as I mentioned, we can classify as an acid-soluble collagen or pepsin-soluble collagen or PSC. And when we take a look from the solubility, both ASC and PSC have the high solubility in acidic pH range and the lost the solubility in the neutral pH range or alkali pH range. So this is typical for collagens. And that's why the native collagen is have several kind of disadvantages. The first one is like have the lower absorption in body after intake. That because the large molecular weight. And also it's insoluble at neutral pH. And of course, it's difficult for you to fortify native collagen in the drink, like a milk, because it's not soluble and it precipitates out. Okay, and the other one is if you want to produce native collagen, you have to conduct the extraction process at low temperature, like 4 degrees Celsius, to avoid denaturation of native protein, native collagen, triple helix. So that's why hydrolyzed collagen has drawn attention from both a producer and consumer. That's because it's water soluble in nature, and also they have the higher bioactivities, which I'm going to talk more today. And when you take a global fish or collagen peptide market, it was estimated to be $250 million in 2021. And the industry is further expected to grow at 8.2% during 2021 to 2026, around 5 to 6 years from now. And a global fish collagen peptide market can be divided in the different segments. You can see that the largest segment, more than 50%, is go to bone and joint health. Because the people know right now that, okay, if you take this collagen as supplement, they can have the better bone strength, and also joint is good, better. And also they can use for nutraceutical, cosmeceutical, and also pharmaceutical. And in fact, for fortification, which I think I'm not sure in Indonesia, but in Thailand is the drink or some product fortified with hydrolyzed collagen is very popular. Basically, these hydrolyzed collagen produced from the fish scale or oosin. Oosin is kind of demerized scale, but the problem is the lower yield. But the advantage is no fishy odor. That's why they prefer to produce the hydrolyzed collagen from fish scale rather than fish skin. So how about fish skin? Because I mentioned that it's a byproducts. So what we have to consider when we use the fish skin as a raw material for production of hydrolyzed collagen, one thing that we have to focus is the fish, the fat distributed in the fish skin, and this fat contribute directly to fishy odor of resulting hydrolysis. You can take a look from here. You can see this is kind of like the images of the fat distributed throughout the skin. We stain with the 9 blue A and using confocal electron microscope. You can see the red dot here is represent the fat distributed throughout the skin. And also the skin of the sea bass, Asian sea bass, they rich in the PUFA. You can see from here that among all they have the constitute around 41.5%. And also they have the EPA and DHA at high content when compared with other fatty acids. So this means that these one with the fish skin have the high PUFA, they prone to oxidation. So what happens is in the present ocean that can undergo the propagation, initiation propagation, and they form hydroperoxide. And hydroperoxide is not stable and decomposed to be lipid oxidation products. But this causes a fishy odor. And how to improve the, if we want to use a fish skin, how we can improve the product, hydrolyzed collagens. The first thing we have to consider is to improve the defatting process. So today I'm going to talk about what we have developed in our center. So we use lipid together with polyethylene film and vacuum impregnation. So this is a vessel that we use. First, we have the tank like this, and we have a vacuum system. And you can see from cartoon here, we have the fish skin. And fish skin, firstly, we have to treat it with PF, polyethylene film, and with the electroporation, so make the pore, small pore in the skin. And when we apply the vacuum, those kind of air is sucked out from the skin. And when we release the vacuum, those lipids can pass through into the skin effectively. And we done for 4 cycles to ensure that the lipase get into the skin effectively. And why? Because we want lipase to hydrolyze the fat inside the skin, right? So this is the micrograph, confocal laser scanning micrograph images. And you can see the control one without any treatment. And this is the skin that after treatment by our process, you can see that very negligible fat retained in the skin. And also when we produce a hydrolyzed, stand for SC, using the skin that we select, we develop the treatment. I mean, using PF together with vacuum impregnation with the lipase. You can see most of the volatile compound is become less, especially for hexanol, which contribute to the hexanol. And this one, the control one, you can see abundance of a lot of the compound, volatile compound, including aldehyde, ketone, alcohol, those things that contribute to pitchy odor. But however, if we compare with when we use the isopropanol as a solvent, anyway, when compare with the 2 columns, the one that we develop using lipase have the less abundance of the volatile compound. So the result indicating that the process we developed is successfully remove the volatile compound from the hydrolyzed products. And we also confirm by sensory evaluation. You can see the red bar here that the hydrolyzed produced from the skin with our process developed in the center. You can see here the fishy odor and fishy flavor that the red bar have the lowest the fishy odor intensity and also fishy flavor intensity. So this confirms that the hydrolyzed collagens have the lower fishy odor when compared with without any treatment, I mean control back bar. And what is hydrolyzed collagen? Basically, you can remember that it's a triple helix, it's native collagen. And after hydrolysis by your enzyme gonna cleave the peptide bond here, and they will come up with a top chain peptide. And actually, they have the the very low molecular weight here. And they have, of course, they have high digestibility. That because we have a small molecule and also absorb easily when after intake, and they can pass go through the body by blood circulation. And how to produce the hydrolyzed collagen? So actually, we have to pre-treat the raw material, I mean, skin. And most important thing that we have to defat this, remove the fat as much as possible. And then we select the hydrolysis process. For example, we can use 1-step hydrolysis process, 2-step hydrolysis process, like this, for example. And also we can select the enzyme type that we can use. And then we end up with the hydrolyzed collagen with different peptide. And this example that we produce, we use the sea bass skin, as a raw material, and we conduct hydrolysis, and we can use from a reactor as well. And this is a sample of the hydrolyzed after we hydrolyze from the pieces like this to be liquefied like this one. And the factor affecting bioactivities, of course, when we talk about the hydrolyzed collagen, we expect for their bioactivities. So the factor determining the bioactivity include the processes used, type of enzyme used, enzyme concentration, and also these lead to the different type of peptide in the hydrolyzed collagen. And of course, they can affect the bioactivities of the hydrolyzed collagens. And this is example that I'm gonna talk. This is a process. We have 5 processes. You see that we use alkylase at the 0.2 unit per gram and hydrolyze for 1.5 hours. And this you use the higher level, 0.3 unit per gram, and use a hydrolyze for 1.5 hours. And this one we use parpane. This we use parpane together with alkylase. We use parpane with alkylase at higher level of enzyme. And you can see from here the 5th one, this one, they show the higher antioxidant activity as assayed by ABTH radical scavenging activity and also DPPH radical scavenging activity. You can see the highest, and also higher than the ascorbic acid, here, okay? And this confirmed that the process used to determine the bioactivity. In this case, I'm talking about the antioxidant activities. And from the hydrolyzed that we selected, we use the mass spectrum, multi-top mass spectrometers, And we found that the peptide have a rate around 800 and also 1,100 Daltons, which is quite small one. And when we take a look from the amino profile, we can see that they also contain, you can see from here, glycine constitutes around 1/3. As I mentioned, that it's similar to mother collagens. And also they contain the high hydrophobic amino acid, which may be associated with the high antioxidant activities. And this also with our study, we published in the 2017, we characterize, identify the peptide and synthesize the peptide. And you can see from here that each peptide, they have the glycine every third position. You can see every third position you could be found glycine as mentioned previously. So this confirms that it's a form collagen. And different peptide, they're going to have different activity. For example, for the first peptide, glycine, leucine, phenylalanine, alanine, glycine, proline, arginine, they're going to have the highest ABTS radical activities. And this is also an example for another skin we call unicorn-related skin. This is skin, and this is how they look like. They have the chymety. So mostly they fillet and export. And you can see from here, by using LC-MS, we found that they have the different peptide. Again, they have the glycine every third position. And since we use glycine endopeptidase from papaya latex, glycine endopeptidase means they prefer to hydrolyze the glycine at carboxyl group. And then you can see that at the end of the C terminal, they have the glycine here. And when we talk about the bioactivity of the hydrolyzed collagen, so the first one we can talk is the prevention of the DNA damage. So in the presence of oxidant like hydrogen peroxide supposing in our body, so in the presence of hydrogen peroxide, you can see that they have the high damage of DNA, the black bar here. And the higher level of hydrogen peroxide, like 60 micromolar, the higher damage was found. However, when we add the hydrolyzed collagen, you can see the damage of the DNA decrease in the dose-dependent manner for both 40 and 60 micromolar of hydrogen peroxide. While the control, they have the very negligible DNA damages. So this confirms that hydrolyzed collagen can reduce the DNA damages induced by oxidants. How about skin nourishment? Skin nourishment is very important for the everyone, because everyone want to have like look younger, So I think no one want this one, right? Wrinkle, deep line like this. So can hydrogen be of help or help you to just like have the lower wrinkle like this? So actually the hydrolyzed collagen have dual action mechanism. So they can serve as building block for formation of collagens. And also they act as the ligand, the binding to fibroblast receptors, So the fibroblast is kind of cell to produce the skin cell. So that's why they can function to boost the formation of fibroblast cell. Okay, so this is one study. They use the 4-week-old male white star rat. They fed the rat with the diet for 3 groups. The first one, control one, standard diet. The other one, they supplement with the 12% casein. And the last one, they supplement with 12% hydrolyzed collagen. And after 4 weeks, the rat was sacrificed and the skin was extracted for protein. And protein was subject to different assays. And this one, they used immunoblotting assay. And you can see from here that the last group that fed with the diet containing 12%, they have the larger band of type 1 and type 4 collagen. And I want to explain a bit more between type 1 and type 4 collagen. Actually, type 4 collagen is the local investment of the skin. Degradation of type 4 collagen is caused the deep line or wrinkles like this. And also when we take the test for the inhibitory activities of the hydrolyzed collagens, so they found that the sample, the rat fed with diet containing hydrolyzed collagen, they have the lower metalloproteases. So it means that they have the lower degradation of type 4 collagen. They use active staining technique for this. Okay. And we also like us to try to increase activities of the collagen to induce proliferation of fibroblast cell related with skin nourishment. So you can see from here that only hydrolyzed collagen, they can increase the proliferation of cell in a dose-dependent manners. However, if we mix hydrolyzed collagen with vitamin C or ascorbic acid 2:1 ratio, you can see that the highest cell proliferation can be observed, and proliferation is in the dose-dependent manners. Also, when we measure the collagen produced in the cell, you can see from here, when we use the hydrolyzed collagen together with the vitamin C at 2:1 ratio, the highest collagen can be produced, and also it's in the dose-dependent manners. So that why it's no doubt that in the market, you can see this kind of product, hydrolyzed collagen plus vitamin C. And because they can help synergistically to produce or promote the proliferation of the fibroblast cell. And next, I'm going to talk about wound healing. So we use the one in vitro scratch assay using fibroblast cell. So we see that the cell first, and then scratch using the sterile tip. You can see the scratch here. At the first hours, you can see here, the scratch here. And after 24 hours, in the presence of hydrolyzed collagen with different levels here, up to the 500 microgram per milliliters. You can see after 24 hours, the one that treated with the hydrolyzed collagen, you can see the smaller gap. And to be easy for you, you can see that the wound gap is kind of lower. However, the proliferation of fibroblast cell increased significantly here. You see? So this one is indicating that the hydrolyzed collagen can enhance the wound healing. And to confirm that, why this kind of gap, can merge together. So we monitor lamellipodium formation in the fibroblast cell. What is a lamellipodium? So it's a branch actin filament used for cell migration. You can see like this here. It's like chlorine. And then when we monitoring, we found that at the 250 and 500 microgram per milliliters, the lamellipodium is the highest when compared with the control one without addition of the collagens. All right, so to move to osteogenesis, is mean the related with bone. So osteoporosis is one of the problems, and World Health Organization had defined osteoporosis as decrease in bone mass by 50% and bone quality by 50%. And 1 in 3 women or 1 in 5 men over 50, more than 50 years old, will experience osteoporosis. But basically, the women have the more problem when compared with the men. And before testing, we use osteoblast cells, and we have to check the toxicity that we found that in the range of 50 to 800 microgram per milliliters, they have no toxicity to the cell. So we move on. So here we monitor the osteogenesis, by using alkaline phosphate test, and you can observe here at the day 7 when the cell was treated with hydrolyzed collagen at 100 microgram per milliliters. You can see the highest alkaline phosphatase activities. So this indicating that, and also you can see from here, the highest intensity. We use a BCITP NBT solution to stain for alkaline phosphatase. And for 14 day and 21 day, you not see much different. So this indicating clearly that this collagen is play a major role in the early stage of the osteogenesis. Okay. And also to confirm that it can differentiate or produce the calcium in the cell or not, we also monitor the cell, differentiation of the calcium in the cell. So after 21 days, you can see that those kind of calcium nodules, you can see that small dot here is like calcium nodules, is produced more in the percent of the hydrolyzed collagen 100 and 200. You can see from here. And this is a graph, you can see more clearly. And you can see that the 120 or 200 microgram milliliters, they can promote the cell mineralization or calcium differentiation, okay, in the cell. This is like the way they can test that. Okay, so now you get some more idea about the bioactivity of hydrolyzed collagen, basically on the skin nourishment, also bone strengthening. or joint health. So now, because actually they have the drawback of hydrocollagen because they still have the fishy odor and also the brown color somehow. So they limit application. So we end up with one technology. We use the liposome. The liposome is a bilayers, produce is kind of colloidal structure and have bilayer, and we can load those kind of target product. In this case, I mean, we load the hydrolyzed collagens, and we use the to produce liposome. They have several kind of method, but this is the one method we call ethanol injection method. We start from the using raw material. So we use a soy lecithin, I mean phospholipid, together with cholesterol as a structure makers, and we mix with and of course they dissolve in ethanol. We mix hydrolyzed collagen here and stir, mix together, and then evaporate ethanol using rotary evaporators, ending up with the liposome, and we freeze dry it. And you can see from here, this is a liposome we obtained that loaded with the different level of hydrolyzed collagen. And this is a freeze dry form. Okay. And we've monitored the size of the particle, and you can see from the liquid form, it have the nano size, I mean, around 67 to 72 nanometers. And for the powder one, of course, during freeze drying, aggregation take place, so they have the larger in size. And for setiap potential that indicating the charge of the liposome, we found that, or they have the negative charge. That's because the phosphate group of the liposome, right? Because we use the phospholipid. So phospholipid going to have the content of a phosphate group, they have the negative charge. And this is from the micrograph. We can see here that we use SEM and TM. And TM, you can see that they have like by layers, vesicle. So inside they load that with the hydrolyzed collagens, like this, like a tunli here. So this one is hydrolyzed collagen, and the same thing here, and like have the hydrolyzed collagen inside. And for the dry one, we used to, like a vesicle and protection the hydrolyzed collagen from the harsh environment. And we store for 6 months at 30 degrees Celsius, I mean room temperature. And you monitor the activities, ABTS radical scavenging activity and DBS radical scavenging activities. You can see that the only slightly decreased throughout the 6 months of storage, but for all the samples, okay. And the last part, we're going to talk about the application. So basically, this is an example. This is a product available in the market. They license our, like a patent from our center and produce this kind of products, collagen drink, and these are from other company. Okay, so, and also you can see that this kind of common thing right now that the people just like take one or couple spoon, in the tea or the coffee or even drink, just to supplement for the collagen. And this example that we did, we prepared the chrysanthemum drink, and then we start from flowers, extracting by using hot water for 3 minutes, and now we mixtures. Add sugar to make it sweet, filter, and add hydrolyzed collagen and bottlings, tap, and then sterilize, use at the 121 degrees Celsius for 11 minutes, or we say that F0 is 7 minutes, cool down, and end up with the drink. And this is the way they look. This is as a function of the time, 1 month, 3 months, 6 months, you can see a bit darker. And also when you add more hydrolyzed collagen, we also get a bit like darker in colors, okay? And we monitor the antioxidant activities, ABTS radical scavenging activity, DPS radical scavenging activity, FRAP, also ORAC. And you can see from here, at the first day, the one without hydrolyzed collagen additions, they have the lower activities. When we add hydrolyzed collagen to the high level, antioxidant activity is increased in dose-dependent manner. For all SAUs, you can see here. But however, with the function of time, when we keep for 6 months, the gradual decrease in the activities was for all sample, for all the SAUs, okay? And this pH, no change much in pH was found for all sample. However, one interesting thing that we found that the lower in alpha amino group, so you can see for all sample, that because they can undergo Maillard reaction, because the free amino group in the peptide can undergo Maillard reaction with other component in the drink, and that's why they cause darker in color as well. All right, this is almost the last slide, that cosmeceutical. So we also work together with the faculty member from pharmaceutical science faculty, and we develop this kind of lotion, serum, cream. Yeah. So this is just a last slide that we have volunteers, 30 volunteers to apply the serum for week 0 and week 4. You can see that after week 4, the pore is kind of much lower for this lady. You can see the forehead, the dot represent the pore. It's much lower, and also this one also lowers. And this lady also, you see that the dot is kind of lower. Okay, so that's why we're still working on this one. All right, so I want to end up with my summary that fish skin, a byproduct from fish processing, should be fully utilized to increase the revenue for the processor, and new value-added product, particularly nutraceutical and cosmeceutical, with higher value must be further developed that enhances the exploitation of fish skin. So thank you very much for attention. Thank you.
Thank you very much, Professor Soottawat, for your interesting presentation. We have seen from his presentation about the technology to overcome the fishy odor of the hydrolyzed collagen, and also their function in promoting the health of skin and bone, which is very important for women, I think, Professor Soottawat, and also the application in the product. Thank you very much. So, ladies and gentlemen, now we come to the question and answer session, which I'm sure that it is what are you waiting for to discuss with all the speakers. Now, let me give this opportunity first to the question that is delivered to Professor Rashid. I see several questions has been typed in the comment column, and also some of them is already responded by Professor Rashid, but let me summarize the question for Professor Rashid. So question from Ms. Rati, which is has the bigger impact between the threat of pollution or climate change or the improper policy to the ocean economic? And also the second question is about the uninterested investment for the ocean sustainability, especially in Indonesia. And what do you think, how to improve such investment in Indonesia? Maybe 2 questions first, and then we will go to the next question. Please, Professor Rashid.
Yeah, so thank you very much for the questions, and they're very important and topical because many people are interested. For example, between pollution, climate change, and overfishing, which I guess is the policy part of the question, right? So ineffective management of our ocean. At the moment, from our work and my reading and my conversation with colleagues, at the moment we believe that overfishing through ineffective management is the biggest threat to fisheries. Why? Because it is the one that directly takes fish out of the ocean, right, at the moment. Now, climate change is an indirect effect. The ocean is warm, you move, or acidification, deoxygenation, and then pollution is also indirect. But the fear is that in not too distant future, climate change will overtake this, because as the ocean is warming and acidification is increasing, that impact could actually overtake that of ineffective fisheries management, for example. So that is what I understand at the moment. Now, investment, very important. That's the finance part. And your question actually was part of the reason we first go about identifying what are the barriers and then working through. Now, for Indonesia, and I think you're alluding to also developing countries in general, you know, and there we stress a lot about capacity building and just training people in finance and investment and insurance, actually, you know, how to do that in the private sector. But we also stress a lot the enabling environment, because this is important. Like, if you just take all the investment needed in the ocean economy, you can categorize them into three groups. One, you have ocean economic activities that are very profitable. They can compete in the market. And so for those ones, you don't need to worry. The private sector will go in because they make money, right? So that's easy. And you can talk about agriculture and some fisheries, right, are very profitable. Now, there are other types of investment where the returns for business is actually lower than the market return. They give you return, but not that big. And this is because there's a lot of non-market values, right? The society, we want nutrition, we want to feed people, and we want to maintain the ecosystem. So there, I think partnership between the public sector, philanthropy, and the private sector is important, because then the gap, we have to fill that gap, and that comes through philanthropy and the government sector. Now, there is a third group where you don't get any return at all. It's valuable, it's all non-market, you cannot monetize it, and there we just have to have public and philanthropy to finance what we need to do to protect the ocean. All right. There's a lot of activity here in developing countries, actually developing instruments to help it do it. So, yep, in the paper and the report. Thank you.
Thank you. I think that is very clear. And comes to the next question, still for Professor Rashid. What is your perspective about the region which has the conflict of interest, such as in Southeast Asia and in Indonesia? We have some region that have a conflict of interest. How to sustainably manage and solving this issue?
Yeah, that is tough. And I think the question, the person mentioned the South China Sea as an example, right? So this is on the conflict area, high-level politics.
Composition. So this is the background of our research. Before this research was done, the study about
Sorry, anybody? Would you please unmute? Okay. Can you unmute your microphone? Okay.
So when you think of the South China Sea, it's a lot of politics, it's a lot of high-level conflict. You know, you have China and all the countries, what they're doing. So those are difficult to manage because you need collaboration in order to manage these joint systems, because many countries have the right to fish in the South China Sea. Now, the way I've seen this solved around the world is actually for the nations to say, okay, there's all this politics. You can go and do your politics, but for the sake of our fishing communities, for the sake of food security, you take our fisheries out of this big fight. We manage the fisheries well. And I can give you an example. Norway and the Soviet Union, even at the height of the Cold War, there was all that fight between Soviet Union and the West, but Norway and Russia and Soviet Union at the time managed to cooperate to manage their cod stocks in the Barents Sea. It's quite beautiful, right? So it's really trying to package your problems, put them in boxes, you know? I mean, we fight on some things and we cooperate on some things. And I think that's the way to deal with those kind of areas. Yeah. Thank you.
Thank you. And the last two questions, I will read it together, these two questions from Dr. Riza. Can you explain what is the confidence level on the decline of the fish resource in the tropics? And also the last question from Pak Swadi. Would you please advise few example about the solution example to closer to the achievement of ocean sustainability through the finance?
The finance, yeah. All right, so the confidence interval, this is a lot that my colleagues, stock assessment people really work on. And they are all estimates, you know, and they usually will build confidence intervals around that. What I can say about that is from all the numbers I've seen, sometimes there is a bit different. Some say the bill fishes or tunas are down by 90%, and some will say by 76%, right? So you'll have a range, but in general, it's down, right? So the way I deal with it as an economist, I say, even if half of the estimate, only half is correct, the decline is still substantial. So you got to do something, you know. So it's my pragmatic approach to this. But I'm sure a stock assessment person will be able to answer that a bit more precision, right? And
look at me, look at me, look at me. Look at me.
Sorry. Committee, can you
this is live. This is real live. That's good. So, and the second question is about, what was the second question again, please? Sorry. The second question is, can you remind?
The second question is about the example. The example of, wait a minute. Few example about the solution which closer to the achievement of the ocean sustainability through finance.
Yeah, through finance. I think one of them, there are many ways you can look at this and answer this question. But I really think one of the key things, one of the way to do it is to look at all the funding, public funding in particular, philanthropy, foundations, that goes to support the ocean. We look at that and make sure that those monies are used to support sustainability and fishing communities, right? Why do I say that? When we look at subsidies, for example, $35 billion is the estimate, global subsidies. 22 billion of that is classified as overfishing subsidies, fuel and buying engines for people. They go to take the fish down and then make it harder for people to catch fish next time. So if you can redirect this subsidy to, for example, train people, you know, and even support activity. For example, in Germany, they say, we will use our subsidies to pay fishers to fish for plastic rather than fish. So you have a system which is overfish and there's a lot of marine debris. You will use subsidies to pay people to go clean the fishes. So they give the fish a break, you know, they get their livelihood, which we all want, and the fish come back, so we get better food and more jobs for people. So that's the kind of ways we can create funding that will then create the environment for private sector to really move in and also make money in a sustainable way. Yeah. All right.
Thank you very much, Professor Rashid. So this is the responsibility for all of us, not only the government, also private sectors, and also the community.
Community, absolutely, yeah. We all have a stake in this. You can't sit back and say only government. Government doesn't do anything until we tell the government to do something. So, yeah.
Okay. Thank you very much. Now we move to the second presenter. Some question has been delivered. So from Pak Alim, Professor Erlinda, would you please explain, or is there any predicted economic loss due to the sea lice outbreak in Philippines? And also, is there any fish species which can be used as biocontrol to control the sea lice invasion in the tropics? And also the second question, is there any simple way to overcome the infection of the sea lice in fish? Please, Professor Erlinda.
Okay, I hope you can hear me clearly because we're having very strong and heavy rain since last night. Okay. And I had to mute my microphone so it will not be a disturbance to whoever is talking.
It's clear.
And I am thankful that I did not had any power failure issues or connectivity issues. So thank you. Anyway, going to the first question is there a predictive economic analysis or or cause
economic loss
for the sea lice infection in the Philippines. Well, I'm not sure about the other countries, other members of the ASEAN region, but in the Philippines, we have many small-scale fish farms, and most of the time they do not report their losses or mortalities. So it's really very hard to get figures for the economic losses. That it could be done, but it will require cooperation of the farmers or the operators of the facility, and of course with the help of the social scientists. Perhaps it will be beneficial, no, to include that in the, at the end of my presentation, I gave a list of potential research areas that could be taken up. So maybe we can include that there. But sadly, it's very difficult to get the economic analysis of this, no, because of the issues that I have presented. And then the second question is, what is that? Biocontrol. Okay. If you look at the literature in EU or Canada and other countries, they have been using wrasse and lumpfish for biocontrol, no, as cleaner fish. Now, in the region, in the Southeast Asian region, I have not seen any published report on that, but there are anecdotal reports, no, on the use of fish or cleaner fish as a biocontrol. In fact, when I was still in SIFDEC, I used to remember that we were using wrasse as control against leech infection on grouper, I should say, you know, on grouper broodstocks. The problem with using cleaner fish like wrasse is its availability, because they had to catch or collect wrasse from the wild. So if you do that, if the practice is intensified, then we might be encountering supply problems, no, or issues. So that is one. Okay, and for other countries like Indonesia, maybe I did not see any published literature or report on that. And then the other question is on
is the simple way to overcome infection.
I wish I can give you a concrete answer, but if you look at the Lepidopterus salmonis infection, no, in EU and other in Northern America, they have been studying about sea lice control for 4 decades now, but still it's still a big problem. So I wish I have a concrete solution to that, because we are experiencing that, as I have presented in my presentation, no, earlier in the Lepidopterus spinifer infection on pompano broodstock. It is perennially occurring. So we do all sorts of treatments like regular freshwater treatment, but still, no, after a few days, infection again is an issue. So it's a continuous problem. So I wish I have a simple solution to that.
Okay, so still need the research to overcome the problems.
Yeah.
And there are still some questions for Professor Erlinda. In your opinion, what is the factor that is affected the level of pathogenicity? Because some of the species affect the mortality or cause the mortality, but some they don't cause the mortality. So what is the factors? And the second question is the identification of a species of sea lice is very important. And what is your suggestion for the methods of identification? Is there any molecular based identification that is enough and reliable enough for identification?
Okay, as to the factors that affects pathogenicity, or why some species are pathogenic or most are non-pathogenic, well, I think that should be a good news to us. Otherwise, if all species are pathogenic, then the problem is aggravated. So if you remember my presentation, I gave only about maybe 5 species that we should look into. And I think the number one factor there is the specificity of the sea lice species on the host, or its host specificity. Epidemicus it has very low host specificity, meaning it can infect any kind of host species. And other one will be the distribution of the sea lice species. Epidemicus is widely distributed. It has been recorded in I think more than 30 countries, causing disease problems and mortalities. And then the ability of the sea lice species to transfer host, its mobility. It can switch to any host species that is within the surroundings of the sea lice species. I think those are the 3 most important factors that affects the pathogenicity of the sea lice species. And then as to the identification, is molecular tools will be applicable. I think it is, but maybe you can call me a traditionalist or a traditional parasitologist or conventional parasitologist, but I think for parasitology, still the gold standard should be morphology. I'm sorry to say this. I know we have many young students, researchers with us now, and they really like to do molecular studies. Yes, it is helpful, but in the case of parasitology, I still believe that you have to look at the whole morphology of the parasite to be able to do the accurate identification. Of course, molecular identification or molecular tools is also accurate, but in the case of parasites, I think we should still consider morphology as the gold standard. Okay, thank you.
Okay, thank you very much, Prof. Erlinda. Now let me
move. Any other question that I missed?
I think that is, I have read all the questions for you.
Okay, thank you.
Let me move to Professor Soottawat. Several questions delivered for you. The first one, I will read the 2 first questions. In generation of hydrolyzed collagen, that will be a waste of fat or lipid. Can we use this lipid waste for another utilization? And also another question is there any other technique to remove the fat other than the vacuum impregnation technique? Please, Professor Soottawat.
Thank you so much for the question. Actually, we want a zero waste concept. So it means that it's a good idea to utilize all the things. And like fat from the skin, also from the flesh itself, the rich in the pulfar, which is good for health. Actually, the EPA or the HA that we have been known. So from that one, we can use to like other supplement as well. You can see from the market that there are a lot of fish oil, krill oil, shrimp oil, and now we also work on shrimp oil as well. And we found that they rich in sulfur. But one thing that you have to deal with is you have to do purification to lower the fishy odor, undesirable or odor of smell. And then you have to come up with the way to just protect them from oxidation, further oxidation, like you have to put in capsule, or you have to put together with the tocopherols, our Marine E, for example, so they are packaging together. So that's very important thing. Otherwise, those type the oil that you recover can be like a deterioration by oxidation process. Okay, so and the second question is the other technique that we use. Of course, you have. Because this one is kind of like lab scale, and we need to upscale also for like applications. But we also have other technique, to just like maybe remove the oil after hydrolysis. But that oil basically dispersed uniformly is kind of emulsion. So you will have to break down emulsion to separate the oil from the hydrolyzed collagen. I mean, the liquid you mentioned that hydrolyzed collagen. I show you one picture. And those kind of fat is kind of distribute like an emulsion. So your challenge is to collapse the emulsion and make the fat release from the hydrolyzed collagen. So you have to use combined techniques together to just effectively remove those kind of oil. Otherwise, after you have even like a small amount of the oil or fat in the hydrolyzed collagen. Especially in the dry form, you can imagine the dry form is mean a huge surface area, and the air going to contact directly with the fat. So it's undergo oxidation much easier. So that's why I focus on how to defat the either for in raw material or finished product as much as possible. Okay.
Thank you very much. Another questions for you. Is there any difference between freshwater fish and seawater fish skin in terms of the functional properties? And also another question is, what is the advantage of using the skin byproduct compared to other byproduct from fish? We have another byproduct like guts and other thing. And what is the advantage of the skin compared to other byproducts? And also the last question is how to maintain the stability of the collagen when you apply it in the fortification for drink.
Okay. All right. Actually, we are also starting to use like some freshwater fish like a night tilapia, because we can culture it. So easy to just like get and ensure the quantity that we can use for production of collagen in terms of industrial scale. Because now I would say that once we have the COVID, those kind of industries closed, and we have problem with the raw material. That's true. So that's why we have to just like ensure that, okay, we have to have the contact farming that can provide us, those kind of skin continuously. That's very important. But in terms of functional or bioactivities between those two, I mean, between the freshwater one and also the marine one, we never compare it, but they have a lot of literature using the night tilapia as or maybe like a carp as a raw material. But I myself think that, okay, basically, the collagen itself, they have like a similar sequences, but the most important thing that how to produce it, what kind of enzyme that you use it. For example, if you use trypsin, they have the specificity in cleavage of peptide, and you end up with the peptide with different sequences, amino sequences, and those different sequences of the amino acid gonna determine the bioactivity. As I show you some slices, right? Because that's very important to determine. So now we can, if you want to like synthesize the peptide with high activities, we have identified first what is the sequences of the peptide, what the size of peptide. That can be achieved by develop the process, appropriate process to end up with that one. Okay, so I would say that you can use both fresh water and marine fish skin as raw material just to exploit and fully utilization of the skin, which is byproduct. Okay, it's clear for the first question. All right, and the second question is advantages of the skin when compared with other leftover like a scale, bone, okay, or swim bladders or internal organ. Most one thing, okay, compare with the scale. Actually, scale in Thailand, we import the ozone. We call ozone. Ozone is demineralized scale. It's kind of bulky, okay? And then the processor or manufacturer, they can hydrolyze it, but they get very low yield when compared with the skin. This kind, you know, obviously see that the skin provide much higher yield when compared with when you use bone or a scale. That thing that very important in terms of economy. Also, we have to think that when we produce something, we have to get higher yield. All right, but they still have limitation for skin. Like as I mentioned, as I give a talk that fishy odor that very is kind of drawback. So we need to just like go further and develop the process that you can implement it easily for industry. And that's very important. And you see that in Indonesia also, you go to visit the fish processing industry, a lot of a large amount of skin generated. So I myself, I think it's kind of it's advantageous to use the skin rather than the scale or bone. Bone also, you have to demineralization process, you see, and you can see in the bone, they have collagen together with calcium hydroxyapatite. We also working on that one as well. But we see that in the bone, they have collagen, but small amount. So you have to add the extra process, I mean, demineralization process. You see it's costly also. So that's why I prefer skin, but still challenging for us to just improve the quality as well as fishy odor. All right, is this okay? And the last one is what? To maintain, okay, to maintain the bioactivity actually in the drink, right? When we fortify it. So I think it depends on the material inside. But when, for example, the one that we show you that about the drink that we can see the decreasing of the bioactivity during as a function of time. That because some reaction take place, you know, during the storage. So one of them is a Mada reaction. You can see the darker in colors. And once a Mada reaction occurs, it means the N-terminal is gonna, amino group gonna link together or bind together with carbonyl compound, anything that they have carbonyl group. So this kind maybe leads aggregation, some aggregation and loose activities. So I think we can lower the loss in activity by keeping in the cooling temperature like a refrigerator. But anyway, the purpose of this sterilized product is mean that we want to keep in the room temperature, right? And easy to transportation without the keeping in a low temperature. So, but if you want to like, clarify somehow, you have to put in that one to lower the reaction. But of course, it's not spoiled by microorganism because all this microorganism is kind of killed by sterilization process. But like freezing, chemical reactions still take place. Even though you see in the sterilized drink, still have some reaction take place that lose in the bioactivity of the collagen, but it's not too bad actually. So they have some limited time. So maybe like a industry or manufacturer can say the expire date is when something like this. Okay.
Okay, thank you very much, Professor Soottawat. So ladies and gentlemen, I think we will almost reach the last part of this session. We have been going through a very insightful presentation in various topics of marine and fisheries, start from the ocean economics, and then we move to the fish parasites, and we move again to the fish skin hydrolyzed collagen. So I will not make any conclusion for this session, but I hope that this incitement will bring you new idea for your scientific perspective. I will take this opportunity to send my sincere gratitude to all of our speakers, I will give a big applause from here, maybe from all the audience also, for all the speakers. Thank you very much for your kindness, sharing your experience and also your expertise with us. Thank you very much. And I will give this time back to the MC. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Very much, Ibu Indun, for leading the session, and also to the speakers for delivering such informative presentations.
Thank you.
Ladies and gentlemen, those are the agendas we have presented to you this morning. Now, we would like to take a documentation of this event. So we request for participants to please turn on your cameras if you don't have any connectivity difficulties.
So all participants, please kindly turn on the video so we can take a photo together. Okay, to the first slide. 1, 2, and 3. Then the second slide. 1, 2, and 3. To the next slide. 1, 2, and 3. To the fourth slide. 1, 2, and 3. And the next one. 1, 2, and 3. And the last one. 1, 2, and 3. Thank you.
Terima kasih.
Thank you, Professor Rashid. Thank you, Professor Soottawat, and thank you, Professor Erlinda.
Thank you.
You all. Thank you.
Rashid. Nice to meet you again.
Pleasure. Thank you
very much.
All
Thank you
right.
so much.
Very much. Thank you, Paul.
Good night to you
Thank
from
you very much.
Thank you.
Yeah. All right. Take care.
And
Take care.
Thank you. Thank you very much. Now, before we close this opening ceremony, we have a little announcement. We will have a short break before we enter the parallel session that will take place at 1 o'clock. We kindly request for participants to please return to this meeting room again 15 minutes before the session starts. Ladies and gentlemen, we have finished the plenary session today. I am Ratno Yulifenia as the MC today, and I sincerely apologize for any inconveniences that may have occurred throughout this event. Thank you very much for all your participation and your attention. And please enjoy the symposium.
Bye.
Thank you.
Thank you.